Hi there once again, and welcome to another Expresso mechanic tutorial. And this will be the 14th episode in the series Expresso Nuts and Bolts. And in this one, what we're going to be doing is looking at the hierarchy node. We're going to be taking a deeper look into this. Specifically, if we just click on it, we're going to be interested in the start and iteration paths down here and what they'll actually allow us to do. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. On the screen we have 4 cubes. Now our rear cube, which is this one, contains the front row of cubes. And I've grouped these into a null. Now this is our hierarchy, and we can, in our Expresso here, see that we've got a hierarchy node already in there. Now in the paths here, we've got a start path which contains a D and an iteration path which contains an N. Now the D stands for down, the iteration path next. So we can be pretty sure, because we've done similar things to this before, that if we were to put, say, let's think, what do we want? If we say object index, we'll grab a hold of one of those, put an object index in here, and we plumb the output of the hierarchy into the object index. We can now work with our instances, so our cubes, and we can also work with the index values for those cubes. And because our hierarchy, if we see where it references, if we select it again, it references this null. Normally when you put a hierarchy in place within an Expresso tag, it will reference the object that you've put it on. So it would normally reference null 1, but we've changed that here, or I've changed it here to null, which is what I want. So let's see where we go from here. If we were to bring in, say, a math node, let's just bring one of those in, and we change this to a multiply and connect the index to the input 1, and we multiply by, say, let's go 40, just to demonstrate this. And then we get a hold of one of our cubes. It doesn't matter which one, we'll just use cube for the sake of it. We can connect our index to here at an object port, and in the coordinates, if we bring a coordinates port in, we'll say position X, and we connect the output of the multiply, and at the moment it isn't working. Now why would that be? We've got our instance plumbed into the object port of the cube, we've got our output from the multiply plumbed into the position X, and we've got the index values coming in. So why isn't it working? Well, at the moment the index value is 0. If we just get a result node, we plumb this into here, we can see the index value is 0. Now the reason for that is because we've gone in our hierarchy here, we've gone down. So from the null, we've gone down 1 level. And then we've said next. Well, there is no next, because we need an object at the same level as this cube. So if we say D next, straight away we get a result, because we've gone down, down, and then we've said next, and we've sequenced through all of these cubes. So this is really important when you're working with hierarchies. You've got to understand how to work with the different levels and what the start path and the iteration path are actually doing. Okay, so we can see our result is 2, because this is 0, 1 and 2. That's how that's working. So down, down, next, and that's making this thing work. Now if we were to put another math node in, let's just command drag to copy this one, plumb this in here, and we'll make the function of this a subtract. What we'll also do, we'll change this back to the gap between our cubes, and we'll make this 21. Our cubes are all 20 by 20 by 20, so we'll say 21, so there's a little bit of gap between. And then in our subtract, we've straight away they jump back because we've not connected everything else up. If we subtract 21 and we place this in here, we now get what I had initially in the scene. It sets it up for us automatically. So that's all been done using the index output here. That's really important. Yes, we've had to set things up in our start path, but the important role that the index is playing here cannot be overstated. Okay, so that's important. But let's try a different scenario. So if we shut this down and we enter this particular file, now you can see that this is a lot more colourful than the last one. Now what I've got here, I've set things up. This is basically to illustrate how the hierarchy is going to actually perform all of this. If we look at our cubes, we've got a null here, which is represented by the star. That's the null. Cube number 1 is along the back row. And then I've got cube 2, cube 3, and cube 4. Now these, if we shut them up, they're directly under cube 1. And each one of them contains another cube. So the next row, cube 5, 6, and 7. They're contained within 2, 3, and 4. Okay. Now, how do we work with these if we want to make the arrow point at a specific cube? How would we go about doing that using the hierarchy node? Well, let's just open this Expresso expression here and take a quick look at what we've got. So we've got the hierarchy, we've got an object index, but if you look at the index here, nothing is being plumbed into it. Everything is being done with this via the start and iteration paths. Okay, that's how I'm making all of this work, and all I'm doing is basically getting the index values for each of the individual cubes and then passing their positions to the arrow. That's what we're doing here. So I've got the vector to reals, I've got my add node here, that's adding 25 to the Y position of the arrow to make it float above the cubes. That's all this is doing. And then the positions, I've got the instances being plumbed into cube number 2 on this occasion, getting its global position, doing the do with the vector to reals, and the X and Z positions I'm just taking directly from the cubes themselves. I don't need to change those in any way, and then I just pass all of this to the arrow. So that's how that's working. Now, if we select the second expression here, I've added some user data, so I've got a cube index value. So my cube number 1 is what we're currently pointing at. And we can see that the start path here, and if we go into, let's have a look, where are we? If we just select this, and what we'll do is open this in a separate window so that we can see it at all times. Okay, so we've got it here. So we can see our start path is D, represented over here. Now, if I then select my next cube, 2, so we've got our 2 here, our start path is down, down, and that makes sense because we start here, we go down, we've selected cube 2. But let's see what happens when we start collecting or selecting cube 3 and cube 4. Let's see how that works. Now you'd expect it to perhaps be down, down, next, and in some kind of next, wouldn't you? That's what you'd expect, and you'd expect the next to go in the iteration path. Well, let's see what happens if we select the next cube. Aha! Well, we do go down, down, next, but the next has to go in the start path on this occasion. So it's not what you expect it to be. It works in a slightly quirky way. However, if we want to select cube 4, let's do that. It is down, down, and next, but this time another next goes in the iteration path. So that's allowing us to do that. Now, for cube number, where are we? We want cube 5 next. So cube 5, well, you'd expect that to be down, down, down. So let's see if it is, if we select cube 5. And yes, it is. So that one's a simple one. It's exactly what we think it would be. Just go down 1, 2, 3 levels and you select cube 5. So how do we go about selecting cube 6? Well, let's see what happens now. So now we've got a strange scenario again. We have to go down, down, next to get to cube 3, and then down again to get to cube 6. So down, down, next, and down. So it's slightly quirky in the way that this works. Now let's see what we do when we select cube 7 finally. So this time it's down, down, next, next, down. It does make sense actually when you start to look at it, but it is a little bit quirky in the way that it actually operates when you first start playing around with it. At first, I was a bit confused by it all, but it does actually make sense. So that shows you how that works. So if you wish to do something like this, and you want to work with specific elements within the hierarchy, and this really is a hierarchy containing other hierarchies when you think about it. And if we can illustrate that, actually, if we go into Expresso expression here. Now this index, not used, but let's just see what happens when we plumb a result node in and take a look at what we're actually getting. So our index value for cube 7 is 1. Okay, and that's interesting in itself because it's grouped into cube 4, and you'd think it would be 0, but it's not, it's 1. So let's just skip back to cube 6, and again this is 1. Cube 5 is 0. That's interesting, isn't it? So this works in a way that's not at all logical. If we just go back to cube 4 and see what we get there, cube 4 is 1. So that even that is ridiculous, really, in terms of how you'd expect the index value to actually work, because you'd expect that to be 0 for the cube 2, 1 for cube 3, and 2 for cube 4. But no, cube 4 is 1. And let's see what we get with cube 3. So cube 3 is 0. So 0 is starting here, 1. So what will cube 2 be? Will it be 2? No, it's still 0. How weird is that? So in this situation where you've got a hierarchy containing other hierarchies, there's no point in trying to work with the index value here. It works in a very bizarre way and not a way that makes any logical sense. So I would advise you to forget all about it and just use the hierarchies start path and iteration path and just get familiar with how you need to make them work. So there you go. That's what I wanted to show you in this tutorial. So, this is really just about it. I don't need to show you any more than that. And hopefully it's given you a deeper insight into how this all works within the hierarchy node. And you can see that it is actually quite powerful. I mean, it allows you to set up a scenario like this where you can actually select certain elements within a hierarchy within another hierarchy. So, it is quite a powerful node in itself once you understand how these two things work and how you can use them. Now, I've got another expression here, and this is the expression that I'm also using to control what's happening with regard to the text here. That's essentially what I'm doing there. And I'm also controlling the hierarchy. I'm passing what's coming out of this Python node both to these text splines and to the hierarchy itself, to the start and iteration path of the hierarchy. So the Python, it's really simple actually. All we're doing in there, I've just set up a list for the start paths, a list for the iteration paths, and then it's just an if, elif, else situation. So whatever's coming in from the Expresso here, and that's from this Expresso, it's the user data that's coming in. So this user data is being passed. I'm having to subtract 1 because lists always start with an index value of 0. So I've put a subtract in there to take that 1 off my value that's coming in from the Expresso. And if we take a look at the Python code, you can see that the first if statement is saying if cube is equal to 0, which perfectly illustrates the reason for doing it. So that's a simple setup there. That's all I'm doing. I'm just looking at the different scenarios and outputting whatever I need to output from these lists and passing that to the text splines and to the hierarchy start and iteration paths. Hopefully that all makes sense. And if you do want the file that I've got here, if you want this file for yourselves, just let me know. Just send me a private email. You know my email address. And I will happily send you the file so that you don't have to worry about building this. It'll just be there for you. But it's just for illustrative purposes. It's just to show you how this all works and to sort of show you that it is a little bit quirky in the way that it actually operates. And as I said, to illustrate the fact that you just don't want to use the index value at this point because it's just not going to be your best friend. Okay. Well, that just about brings us to an end of this tutorial. So as always, I really hope you've enjoyed this one and that it's given you a bit of a deeper insight and given you some ideas for things that you can perhaps use in your own projects. And if you have enjoyed this tutorial, then please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, then please do share this video. Google are getting a little bit naughty at the moment, and it's becoming more and more difficult to get viewing hours for the channel. They want me to spend money on advertising, which I'm not prepared to do. I don't see any reason why I should pay them for advertising. So any help that you can give the channel would be greatly appreciated. But anyway, that about wraps this one up. So I'll see you very soon on the next tutorial.